My name is Dave Height. I'm the Director of Product Development here at Galvanic. So today we're going to talk about our ProTech903 for measurement of arsine phosphine. The ProTech903, we actually have several models of this available. The one we're going to focus on today is the one we call the 903W, which is shown in the picture here. Basically, this is our third generation of tape-based analyzers. We've had many years of experience with this type of analyzer, measuring H2S and total sulfur. In the past about 5 years or so, we've expanded our capabilities into measuring other analytes such as arsine and phosphine, phosgene, chlorine, and a couple of other different ones. So today we'll focus on the arsine. So a couple of the features of this analyzer as it relates to this measurement. Very low detection limits. Typically we quote as a specification a 5 ppb lower detection limit. That would be a worst case. In reality, generally it's less than that. It's usually around 2 or 3 ppb. We do have some built-in predictive alarming capability with this. So even though it's a tape analyzer and it does the measurement in batches, we can have a built-in algorithm that will quickly detect an excursion, and it can usually detect that in around about 20 seconds or so. If we do go outside of the range of the analyzer, with that predictive alarm, we also use an algorithm called peak detection, which allows us to measure about an order of magnitude above the range of the analyzer. So if you do have an excursion, we can still measure and track the process as it comes down, even though we're off scale. And we do offer also an onboard calibration. Typically, arsine is not available as a bottled cal gas standard, so we do offer an onboard permeation device that can be used for calibration and validation. So the main application we're talking about here typically is for catalyst protection. We know that arsine, phosphine, some of these compounds can damage some of the catalysts that are used in various different types of chemical processes. So it's very important to have a measurement that can detect those excursions, tell you about the health of your guard beds, and also warn you if something bad is about to happen to your catalyst. So in that measurement, typically the ranges we're looking at are typically very low in the 0 to 100 ppb or 0 to 200 ppb sometimes. Got that very low detection limit, very high sensitivity. So we're able to detect very low ranges and detect excursions rapidly. So with the tape system, basically what we have is the sample entering the analyzer. Typically it will be pressure regulated and flow controlled. The pressure we typically like to see is about 15 psi-G, or around 1 bar. And then we flow it on the order of about 100 cc's a minute into the analyzer. The sample gas goes through a humidifier where it becomes basically saturated with water vapor at that point. And then it enters into a detector system, an optics block where the gas will be exposed, or the tape will be exposed to the sample gas. We also have a vent, a ductor that you see in the bottom left-hand corner here. That is used, it can be driven either by the sample or typically in a refining or PChem situation, it'll be driven by instrument air. But that vent ductor just prevents back pressure from being exerted in the cell. If we have back pressure in the cell, it can lead to some erratic readings. So we like to be able to keep that very constant, that atmospheric pressure. So the humidifier itself, we're using a permeable membrane style humidifier. Basically, we have two types. It's actually the one here in the upper right-hand corner is the the permeable membrane one. This other one is actually a contact. We don't use that one in this application, but the membrane, it's very low volume, so it actually prevents the sample from making contact with the humidifying solution. So you may be familiar with older tape systems where the solution actually, or the gas actually made contact with the solution. Well, this one's non-contact. It just simply picks up humidity through a membrane. In this case, for this measurement, the humidifier solution is just simply deionized water or distilled water will work fine. The tape transport system, typically the tapes we can offer are on the order of 330 to 350 feet. The transport system itself, typically you install the tape on the lower reel and then hook it up to the drive reel, and it simply just pulls the tape through the system as required. One of the things we've done on our most recent version of this analyzer is this little barrel right up here that I'm circling with my mouse. That is a pulse counter, and what that pulse counter does is it actually measures the amount of tape that's pulled through the system very precisely. In some of our previous versions, we were using either complicated clutch assemblies to try to regulate how much tape is pulled through the system, or we were using the change from dark to light to do that. Didn't always work so well, so we installed this pulse counter in order to precisely measure the amount of tape that's pulled through. So the spacing is always even, and plus you can actually predict your tape usage. So the tape itself is exposed to the gas, the sample gas, in this little chamber here. So this is the chamber and the detector assembly here. I'll show you a better picture of it in the next slide. But inside this this chamber is an aperture strip, or something that we call a wedge. And basically that aperture strip controls the amount of gas that is allowed to contact the tape. And we can essentially change the range of the analyzer by changing this aperture strip. So for lower ranges, we want to maximize the amount of gas that contacts the tape. So we use a bigger aperture strip, or in fact, in this case, for very low measurements, we actually use something called a wedge, which actually forces the gas into the tape. So the sensor block itself is an LED that illuminates the tape, and a photodiode which basically reads the reflection from the tape back onto the photodiode. The A to D converter is actually located right in the sensor block. So the sensor block is actually smart. It has some firmware in it that performs all of the measurement right in the sensor block, rather than sending analog signals between the sensor block and the controller. And then behind the chamber itself, there's a compression head here. Basically that seals the tape against the sample chamber, and that's where the chemical reaction occurs. So if we look at a cross section of that sample chamber, we see here, this is the tape, this line here. This is the compression head. It pushes the tape against the cell. And then inside the cell is this tiny little slot here, which is the aperture. So basically the gas is extracted from the process using a probe and typically a pressure regulator to reduce the pressure. Filter it for any liquid or particulate that might be present. At the analyzer panel, it'll be regulated and filtered. Humidified, and then it comes in contact with the tape. And when it comes in contact with the tape, that tape is impregnated with a chemical called silver nitrate. And when arsine or phosphine reacts with silver nitrate, it leaves a sort of a gray colored precipitate on the paper. And we can actually read the change in color on the paper. And that change in color, or the rate that color formation occurs, is proportional to the concentration of the gas that we're looking to analyze, in this case, arsine. So if we were to make a graph of tape darkness on the y-axis versus time, typically what would happen is at the beginning of the cycle, a fresh piece of tape is pulled in front of the sample chamber, and it just is left to sit there. And gas is allowed to flow past the tape. And as the tape changes color, the blue line here represents the increase in sensor output as the tape changes color. So you kind of see at the beginning, the increase in millivolts is kind of slow. At some point, it will become linear. And if you really left it long enough, at some point it would flatten off. Basically, the tape would run out of reagent and it wouldn't react anymore. So what we do normally to make the measurement is use the slope of this line, which represents the rate of color formation. So basically, it's just the change in voltage, or dV, divided by the change in time, or dt. And then your concentration is calculated by using a gain factor. If you're familiar with chromatographs, this is just like a response factor. And then by multiplying it by the change in voltage over change in time, that gives you your concentration reading. So as far as calibration goes, there's two different things that you can do. One is a color card calibration. What this does is allows you to sort of validate the sensor block. It could be used in cases where a calibration standard is either difficult to get or not possible to get. So this color card calibration, basically you stick a colored card in front of the sensor. You allow the analyzer to go through a calibration, and it can adjust its gain factor based on that. Another much better way to calibrate the system is by using the onboard calibration. The onboard calibration basically uses a permeation device to generate a known concentration of the gas. So this, the yellow tube here at the bottom, this is a GCal type permeation device. So basically this yellow tube is filled with some pure arsine gas. And on the end of it, there's a membrane that allows a known amount of that gas to escape at a known rate. This T here is where a carrier gas will flow past this membrane here. And if you know the flow rate of the carrier gas, you know the emission rate of the tube, you can calculate the concentration of the analyte that you're generating. So in this way, we can have one of these actually mounted on the panel. So on this drawing on the right, the perm tube is located right here. By using some valving, solenoid valve, screen switching devices, we can automatically switch in a known amount of the gas in order to do validations or calibrations. So as far as sample conditions go, typically the sample requirements, we want to have 15 pounds PSIG delivered to the analyzer. Typically at, it says here 1100 cc's per minute. That's a typo. It should be 100 cc's per minute. So it's actually a fairly slow flow rate. It has to be free of particulates and moisture at ambient conditions. Typically, we can allow samples of 0 to about 80 degrees C. The one thing we really want to be cognizant of is the dew point. So we want to make sure that the ambient conditions of the analyzer always stay above the dew point of the sample. So a sample is extracted, it's carried to the analyzer. It flows through typically a filter, something like a coalescing filter here, pressure regulator, and then it enters into the analyzer. So we've got a whole host of different kinds of probes and sample conditioning filters and things that we can use, typically working with companies like Welker and A+ to do those sample conditioning. So I'll just point out a couple different models of the ProTech. Here on the left, we have the ProTech W. That's the one we're going to show you today. There's also a division, a D2 version of it. So both of these models here are Class 1 Division 2. The difference is that the W is only designed for single input, single output. The D2 can have multiple streams. We can add a pyrolyzer to the analyzer to measure total sulfur as well. So you see this is a D2 with total sulfur. This is a Class 1 Division 1 unit with total sulfur. And then we have the international version, or the one that is ATEX and IECX certified. We can offer a variety of enclosures from fiberglass to stainless steel. Typical ambient conditions for the analyzer, 0 to 50 degrees C. They can run on 24 volts DC or 90 to 230 volts AC. We have solar power options available. The analyzer itself is fairly low powered, consumes about 10 watts. Although if we're using the total sulfur conversion furnace, that power consumption goes up considerably. As far as certifications go for North America, we have, as I pointed out, the Class 1 Division 1 and Class 1 Division 2 models. The electronics itself, on the right-hand side is a picture of the main board. In terms of customer connectivity, we have 6 analog outputs available. There are 2 analog inputs available. Modbus through serial, Modbus TCP/IP is available. There are up to 8 discrete inputs that can be used for remote control, and then up to 6 relay outputs that can be used for alarm enunciation. All of the electronics are epoxy coated for use in harsh environments. So as far as the operation goes, there's 2 ways that you can operate the analyzer. One is with a local handheld keypad. What this will allow you to do is check on some of the parameters of the analyzer. You can change a few things. You could initiate validations and calibrations and this sort of thing. Also available is a PC-based user interface that allows you to do a little bit more detailed setup, and it also is available for remote login if you have your system on a local area network. We can use Ethernet to log into the analyzer remotely. Just a couple of examples of some different types of installs here. As far as maintenance goes, typically the maintenance will revolve around the tape consumption. Typically for this application, the tape will last usually around 4 to 6 weeks, depending on the exact length of the cycle. Replacing the tape is fairly straightforward. I'll show you a little bit more detail in a little bit how that's done exactly. The humidifier itself, the permeation tube can be changed. It says here monthly, that's not correct. It would be done more like on an annual basis. The humidifier solution, you can top that off basically monthly or every time you change the tape. The sample conditioning filters anywhere from monthly to quarterly, depending on how dirty your sample is. Cleaning the aperture strip and the sample chamber done quarterly takes about 15 minutes. So maintenance on it is fairly straightforward, but like I said, it really revolves around the tape consumption, how often you're going to do your maintenance. As far as service goes, we've got on-site training and startups are available, commissioning, always available for remote service as well. So we've got a full support department available to answer any of your questions or to do any kind of on-site startup. So just to summarize, ProTech, we're all about measurement certainty. So, with this type of analyzer, you can expect, a rapid return on your investment. If it picks up one excursion that can damage a high dollar value worth of catalyst, then that's a good return on your investment. Good, excellent sensitivity for this application, very sensitive and very speedy response. And Galvanic brings 40 years of experience in the oil and gas industry, especially with the tape-based systems. We've been doing these systems for a long time. This is a typical analyzer system here, so I'm just going to sort of start with the door closed. So basically it's in a stainless steel enclosure. In this case, it is temperature controlled. I'm going to tilt my camera down, I think, just to show you down here mounted at the bottom of the cabinet. This is the temperature controller itself. So typically we can set this temperature to 25 or 30 degrees Celsius. The reason that we do temperature control in this case, there's two reasons. One is that the permeation device that's used for calibration, they typically require some temperature control to maintain their stability. In addition to that, the chemical reaction that we're doing on the tape, it is a chemical reaction that we're monitoring. Temperature is always a variable in chemical reactions, so the more stability we can give to the environment, basically the better stability for the measurement. Basically what we have is inside the unit, so there's the analyzer itself. Take a little bit closer look at that in a minute. The sample entry is up here, the top right, so it comes in through a filter and then through the pressure regulator. Up here is a flow controller, and then it flows into these. These are Swagelok SSB double block and bleed switching modules. We're using them in this case specifically because the customer requested it, but we could use air actuated three-way valves for switching as well. These packages are quite nice because they're nice and compact, and they can be, they're available with silicone coating. So you'll notice too, I don't know if you can see much detail in the webcam, but these devices are actually silicone coated, so that's to help keep them, all the wetted surfaces from interacting with the sample, so it keeps the sample path inert. But in this case, the switching modules are used to switch between the stream and the cal. The cal system is here, so you can see the yellow permeation device. There's a flow meter here. These permeation devices come with a certificate that shows you what the permeation rate is, and from that you can calculate how much flow you need to flow past the device in order to get a desired concentration. Typically that flow is much higher than the analyzer requires. So in this case we're flowing somewhere on the order of 600 cc's per minute of gas through this permeation device. The analyzer only requires 100 cc's a minute, so we actually have in that built in a bypass flow just to get rid of the excess. So that bypass flow can be vented into your vent recovery system. So when the analyzer is calibrating, we have some solenoid valves over here that are controlled by the analyzer that can introduce the nitrogen for the perm tube, as well as deliver gases to the SSB double block and bleed modules to switch between the two. Down here we have a heater, so the heater is connected to the temperature controller. We're using an RTD to feed back the temperature into the system, and as I said, we keep it at typically 25 or 30 degrees Celsius for maximum stability. This is the H2S scrubbing module. So it just fills with lead acetate crystals, and as the gas passes through, any H2S will react on that lead acetate. Doesn't make it through to the analyzer, only the arsine and phosphine will make it through. So the analyzer itself, we can open it up and have a look inside. The tape supply is here. So basically, when you want to replace the tape, you simply undo these guards here. So you can undo the bottom one and the top one, pull the old one off, plug a new one on, basically feed it through the system here behind the compression head, up over these guide pins. Make sure you run it over. This is the optical encoder that counts the tape length. You want to make sure you run it up over that. The analyzer has a built-in tape counter. So typically when you change the tape, you can reset the counter. That's something that you can do through the keypad. And then you can set alarms based on the tape usage. So for example, if the tape gets down to a certain number of feet left, you can raise an alarm that says it's time to change the tape, or you have X number of days of tape remaining as a warning. The sensor block itself, I'll just show you how to access that. This little cover here basically comes off, and this is the sensor block itself right here. So essentially, it's all built into a plastic block, so there's no light alignment or anything like that associated with it. It can only fit into this slot one way. So basically, it just plugs in like that. If I pull back the compression head, you may be able to see on the webcam the red LED shining through. That LED is illuminating the tape, and the light reflection is being read back. So that's all built into this block here. And as the Arsine passes through the system, the tape will turn color, and the sensor block reads it. It kind of takes an average of the rate of staining over a period of time. Typically, this measurement, the cycle times are on the order of 5 minutes. So it does a sort of an average over that 5-minute period, and then it reports a value in ppb. So inside the analyzer itself, you can see here's the humidifier solution. As I mentioned, it's basically just DI water. The electronics that basically controls everything. Here's the stepper motor that drives the tape. As an option, in this one, we've got installed a V-Links module for converting serial into Modbus TCP/IP. That's available as an option, and as I mentioned, we also have a remote login through Ethernet options available. So this is the PC-based GUI or user interface. Typically, it plugs into the analyzer via USB. So on the outside of this enclosure, we have a USB port that you can plug into. As I said, it's also optionally available through a network connection as well. So typically, when you plug in here, click OK and do a login. Just to point out a few of the features, it's password protected. Default password is 2222. Nope. I got to do that again. I can't type. So on this home page, you basically see what your reading is in ppb. In this case, right now it's reading 126 ppb. You can see along the side here, there's lots of information available about the sensor and millivolts and things like that. Down at the bottom, you've got a bunch of tabs, so we can look at the status. It shows you basically what all your analog outputs and inputs, relay outputs and that are doing. You can see any active alarms here, so there's a whole slew of fault alarms that are available. Some of them are warnings about, the health of the sensor. Some of them are actually faults that indicate that the sensor is offline. And all of these are available either through the Modbus or through the relay outputs. There's an archive available. I'm not going to read it right now. There's an event log available as well. There's some setup here that can be done for, again, the global fault alarms, where you want them to go out, that sort of thing. Stream configuration. So here, for example, you can set your alarm set points if you're interested in having the alarm outputs available for your system. We have discrete inputs that allow you to either hook up binary alarms, like a low pressure switch, for example, or you can use them to initiate remote calibrations and things like that. Outputs, as I mentioned, 6 analog outputs available. They can be scaled and set up here, and then your relay outputs, you can set them fail-safe or not fail-safe. There's a sequencer available that allows you, if you're multi-streaming, to sequence those. Serial ports available. There are basically two serial ports available, an RS-45 and an RS-232. You can look at your Modbus map. You can actually program it or set it up. There's essentially a pick list on the left-hand side, and you can just basically, pick up an item and drag it in to the type of output that you want. For example, if I want to put this value out as a float, I could just drop it there. So you can basically program your own Modbus list. If you don't want to do that, we can do it for you. Some analog inputs here that are configurable. Again, we typically use these for measuring temperature, pressure, things like that. And then there's some timers as well, so you can do various analyzer functions based on time of day. So for example, you could set up auto cals or auto validates to happen at specific times during the day. So this configuration can also be then saved on your PC for future use or for download to another analyzer, that sort of thing. Tape disposal. Tape disposal somewhat depends on where in the world you are and what is allowed to go into your local landfill. But what I will say about this is it's silver nitrate, as I mentioned. So silver is known to be an environmental hazard. So typically what we would recommend is that you dispose of the spent tape as hazardous waste. If your plant has hazardous waste receptacles or how you deal with that internally, I'm not sure, but if you can't deal with it, another thing that we can suggest is that you throw it in a box and you can send it back to us and we can dispose of it for you. Does moisture interfere with the reading? Good question. In fact, moisture would interfere with the reading. If the humidity level in the sample itself were to go up and down, that would affect it. But we actually correct for that by having the humidifier in place here. So if the moisture content in the sample changes, we just simply saturate it at whatever the ambient conditions are before it goes onto the tape. So basically that levels out the effect of moisture in the sample itself. If you're referring to ambient moisture, then no, there's really no effect from the ambient moisture. Again, because we humidify the sample, basically bring it up to 100% relative humidity at the ambient conditions, the humidity levels in the air are basically overridden by that. So there's really no effect from moisture. There's PPB, the maximum detection limit can be ranged higher. The answer to that question is yes, we can have higher ranges for Arsine. I think the highest that we've done is somewhere on the order of 5 ppm. But if you have anything specific in mind, we can always entertain other ones. But typically the measurements for Arsine are quite low. What is the shelf life of the replacement tape? So the shelf life of the tape is 1 year. The silver nitrate tape, it doesn't necessarily lose its sensitivity after a year, but what can happen is that it can become sort of brittle. So chances are it'll last more like 18 months, but we do put a shelf life of a year on that. Are there any compounds that interfere with the measurement? Yes, there are. With the silver nitrate method, H2S is a positive interferent. We deal with that by using the lead acetate scrubber, which can selectively remove the H2S. There are other metal hydride components that will react with silver nitrate. I don't think you typically see them in your typical PChem or refining applications. These would be things like borane. There's a few other ones. They don't come to mind right at the moment, but typically they're sort of exotic type of components that you wouldn't typically see. So the two that respond are the phosphate and the arsine. Can rearranging be done in the field? Yes, it can. Basically, depending on what you change the range from and to, it would typically involve changing out that aperture strip that I was talking about earlier. So to make the range bigger, typically we would put a smaller aperture in, or to make the range smaller, then we could put a bigger aperture in. So yeah, it's relatively easy. Typically after you do that, you would have to recalibrate the analyzer. How long would the lead acetate tube last if it was exposed to 1 to 5 ppm H2S on average? I'm not sure I know the answer to your question exactly right off the top of my head. I would think at that level that it would last on the order of many weeks, maybe 1 to 2 months, something along those lines. But as I mentioned, it does have sort of a built-in indicator that indicates when it's spent. So it's fairly easy to replace as well. The actual tube itself, the ends screw off, and then you can just refill it. Does mercury interfere with the measurement? No, mercury does not interfere with the measurement.
Everyone, I do appreciate you taking the time out of your day to join this webinar to hear about the Arsine application.
We've got Ian Tell, who is our VP of Sales and Marketing. We've got 3 regional sales managers in North America. Peter Cartmell's on the call with us here, as well as the platform manager, and myself, Director of R&D, Dave Height.